Hello everybody! Today we're gonna investigate a little bit what is going on about the size of Docker images and why you should care. First of all, I have my example project here, which is linked in the description below the video as an open source project on GitHub. In the last couple of videos we did discuss how we can build our Docker setup for development and for production. And today we're gonna take a look at the size of it and why it's not necessarily a good idea to use the Python 3.5 base image. So first of all, I'm just gonna do, actually I'm gonna show you. I have literally no images here. I have like basically just the one we're using right now, and what's running, nothing is running. So everything is clear here. Docker ps-a also tells you I only have the PyCharm helpers installed, which is something that's coming from a IDE and not from what I'm actually programming. So to start with, I'm just gonna call docker compose build, which is going to build my images, which was rather quick because maybe it was cached or whatever. And if we type in docker images now, that's a command you should remember, you will see that we did just build the Django upgrade video Python image, which has a whopping 751 megabyte. Now, like the base Python image that you can see here also has 695 megabytes, so we're probably adding about 60 megabytes by installing requirements. So, well, and copying like an entry point script and the source code of the application. So what do we actually have in that application that is like, what does it make it so big? I mean, requirements is one thing, sure. Let's see, base.txt has Django, our database connector, and Celery, because that was one of our last videos where we did stuff with Celery as a task runner. And the Docker compose file, basically just for you to know, like it has a Python service, a Postgres service, a RabbitMQ, a Celery worker. But the main thing we're going to focus today that we can control is the Python service here. So let's make this smaller and discuss why we would want to make it smaller. So the first thing is we need to take a look about what's being happening. It's what do? We're copying our whole /app directly. That's this directory here. Okay, there's an SQLite file. I'm gonna leave it here for the purpose of having it because we're running the app somehow. There's a debug.log that doesn't really need to be in the image, right? And well, the requirements file and our settings and some code and whatnot. Yeah. The first thing you would want to do is you would want to take a look at your Docker ignore file if you don't have it. And we've already been very proactive and we said we want to ignore our app tickets debug log, our PyCache, and our virtual env if we have any, like we have here because we had it earlier. But bear in mind that this doesn't mean that these things might end up in our image, because if we say copy the whole app folder, it will probably be in our image. Let's in fact just check it out. So we're gonna say docker compose run rm python bash. So we're just gonna start a bash for our container. Now I've cleaned my complete system. I've got no Docker images whatsoever, so it's gonna start downloading some Docker images. Fine, so be it. Let's do that. And once I'm in the container, I'm gonna go into the app tickets directory and I'll see if there's a debug log and if there's a db.sqlite. It probably is. There shouldn't be, honestly, but it probably is. So yeah. So yeah, you're seeing it's pulling the Postgres layer. It's gonna pull the RabbitMQ layer probably in a second too. There we go, pulling RabbitMQ. One thing you notice here is these layers. We're gonna talk about them. Basically, every step you do in here is such a layer that's being pulled, which is okay in the most cases. But if you wanna make a small image, there might be something we can optimize. Yeah. Okay. And it's creating my containers, and we should be, yeah, there we are. So we want to know if there is app tickets debug. So I'm just going to go to app tickets, and there's a debug log. So this docker ignore doesn't help us avoiding copying this. If we explicitly copy it, it's in there. In fact, the docker ignore is it has a completely different purpose. The idea is that you don't have to rebuild your container. if the input files are the same, like the whole app directory. If we didn't change our code, then there will be a checksum of that directory, and the container knows it doesn't need to rebuild itself if we do docker compose build. But it doesn't mean it's not being copied, so we would have to take care about it here. Or even better, we should just make sure it's not in here, or we can delete it or whatever. For the purpose of doing what we're doing right now, let's delete this file. Actually, let's exit our container too. And let's delete this file. And let's see, Docker images. We have 751 megabyte. Let's rebuild those images. I believe that we will not be able to rebuild. In the meantime, while this is building, I'm gonna show you something from Docker Hub. So if you know Docker Hub, this is where you can find your Docker images. And this is the Python Docker Hub site. So if you go to dockerhub.com and you enter, or hub.docker.com it is now, you enter Python in the search here, press enter, you get a couple of searches and you get the official Python image. That's very important. Always go for the Docker official images. And you can see there's multiple versions available, like 3.8, 3.7.2, but also multiple variations of it, like 3.7.2 Alpine 3.9, or Slim Stretch, or Stretch, or Chassis, or an older version of Alpine. And that could be really confusing, right? In fact, it is really confusing. They often do change things in here. There's new images, new Debian versions, like this is Debian Stretch, or this is Debian, where is it? Debian Chassis is somewhere, I think. There is Chassis still. Slim Chassis is probably a slim version. If you don't get confused, just take a look at this link here. There they have a full documentation about what is what. And we're gonna do that actually, because we need that. And yeah, there's the explanation, the image variance. So you have the version, which is clearly the Python version, so okay, we know that. Then we have version slim. This image does not contain the common packages contained in the default tag, and only contains the minimal packages needed to run Python. Unless you're working in an environment where only the Python image will be deployed, and you have space constraints, we highly recommend using the default image. Now, this is okay, but we can take a look at this if this is still working as it is, right? So let's actually just first of all create a new Scratch file so that you can note down what we have. Generic, whatever. We have the Python 3.5 chassis. So we are basing this image out of Debian chassis. This is an SQL file now, funny. And it has 751 MB, or let's double check because this is just finished. Yeah, 751 MB. So you can optimize the files you copy, but most likely this is not the problem. All right, then we're gonna change. We're gonna say instead of Python 3.5 chassis, we're gonna go from Python 3.5 slim, and we're gonna say Docker compose build. It's gonna have to pull that because I don't have that. But you see the sizes, they are much smaller now. In the meantime, let's prepare what we have in here. So it's pulling these images now. That takes a while, obviously. So building is not the fastest, but it's now executing these commands, and hopefully we should be fine. So it's pip installing now, and should be fine with pip installing. We will see if there's any issues. I'm expecting this container to be, I'd say, about 200 to 300 megabytes of size. Maybe less, maybe more, but around that. This is completely unscripted, by the way. So I'm as surprised as you will be when you watch this video, I hope. All right, it's almost done. Let's see, Docker images. Oh yeah, 193 megabyte. We're gonna double check that this is still working by saying docker compose run python bash. We're still in here. Everything seems fine. We can do python manage py check. System identified no issues. I can double check by saying run server and see if my server is actually running. I mean, I have no migrations applied and stuff, but it should still be fine. So well, everything is good. We've just saved ourselves like a lot. This is not the final word, although there is other images available. There is the Alpine image, which is based on the Alpine Linux project, which is, I quote, much smaller than the most distribution-based images, and thus leads to much slimmer images in general. We can just try. I mean, there's different versions available. We're just gonna try 3.5 Alpine. Let me double check on the Docker Hub page, dockerhub.com. Let me double check what Alpine versions we have for version 3.5 of Python. That's also something you should always check. Like there's so many versions available. Like we've got 3.5 for Alpine 3.9 and 3.8. For the sake of it, I'm gonna go for Alpine 3.9. It's also something you should learn. Always be very explicit with the version you want here, because they sometimes change and then you get a different version. So if you have just Alpine and they ever release Alpine 4.0, then you might end up having Alpine 4.0 instead of 3.9, which is fine in some cases, but not in all. Let's build this one. It's gonna pull the image. It's gonna be much faster pulling because it's a much smaller image. The remainder of the steps should take the same time. Now, in the meantime, why is it important to care about that size? Like 751 megabyte, if you remember, that's about the size of a CD. And you used to be like, oh my god, I need to download a CD with my internet connection. Okay, that's a long time ago. We're now downloading game content, apparently about several gigabytes. The main point still is, this is something that needs to be downloaded. This needs to be stored, it needs to be transferred. And if you plan on using this in production, or like you have like a script that needs to run this image on 10 different servers, then this is considerable traffic that you get every time you need to redeploy, every time you need to reboot, or every time you need to do something. Like GitLab CI runners, if you need to, they usually don't store the images on the CI runner. They're downloading them freshly every time, and that's considerable traffic that you can avoid with literally no implications whatsoever. Speaking about implications, we just met one. Setup UI failed with error code 1 for PsychoPG2, and we need to scroll up and see what's going on. Okay, it's complaining that the PG config executable was not found. We can Google that, but I can tell you what's going on. PG as a Postgres needs PG config binary, which is not within the Alpine base image, but apparently within the Slim base image that we have in here. So what we would have to do to make this running is, first of all, document this, needs Postgres installed. And other than that, literally, I'm just gonna go and Google it. I'm not a magician or something. I don't know this out of the box. So I'm gonna Docker Python Alpine Postgres. Yeah, sure. Like, I'm just gonna take the first link and see what's going on. Harry Liang, blurcat@gmail.com. Big shout out. He just wrote the command that we need, and essentially we're installing PostgreSQL dev and whatever. So we're gonna copy paste this command, but we're gonna modify it a little bit. Again, this is completely unscripted, so we don't know what's going on. First of all, what is he doing? He's calling APK update, which is good. That's good. We're like updating dependencies of our operating system. APK is basically that what you know about apt. So that's like aptitude for Alpine. Then it's adding build dependencies, GCC, Python 3 dev, Muscle dev, PostgreSQL dev, and it's installing PsychoPG2 with pip. This is something we're gonna not do because it's happening down here, so we're gonna remove that. And last but not least, and that's very important, I'm gonna build it in the meantime. He is just deleting the build dependencies here. It's like a cleanup method for APK. This is important because everything you do, it's like a command you execute, it will leave a trace on the system, and this kind of cleans it up. Let's investigate. Let's see, maybe we can fix this. Maybe we see there's like a dependency missing or something like this. Unable to execute GCC, no such file. Or oh, you know what's going on? I'm stupid. I should have read the initial command a little clearer. You know why he did install pip install the thing in here? Because that helps in not having to. Yeah. So this is the right command. We cannot remove the build dependencies in GCC and stuff, because that means we cannot build the library. That was dumb that I didn't notice that earlier. Let's see. This seems to be looking good. It's building something for PsychoPG2. We can then probably remove the build dependency and GCC and muscle def or whatever after building it, but let's just do it like the way it's supposed to be right now. And let's see the size of this image, if it's actually worth it. We're gonna comment this here. It needs Postgres installed, just for the purpose of having it later on. And I think it worked. It did install, so let's finish this last thing. Again, I'm expecting this to be around 100 megabyte, maybe a little bit more, because we have the build dependencies in GCC and all the overhead that comes with it in our image, but we can uninstall that, so be prepared. There we go. Docker images. You caught me there. That's a lot. That's way too much. Run APK delete build apps GCC rebuild. So we're saving us the pip install, I guess, and did it delete? That's the wrong one. I need. Well, I'm gonna guess it did. Or maybe it didn't. Don't know. Maybe it didn't save it. Docker compose build. Nope. Maybe I need to clean. Alpine APK clean. Oh, there's a no cache option. Not sure, why is it deleting .build apps? Was that also here? No, it's deleting build apps. I'm just gonna see if that minus no cache helps us. If not, then either I did something wrong or the Alpine image is not as slim as I guessed. I'm not sure what is going on right now. Maybe the no cache means the same. I'm not an expert. Again, this is unscripted, so doesn't seem to be working, to be honest with you. No. We can try to not use the binary file in here. The binary image, I mean. It's gonna rebuild it again. I'm not sure that there's anything gonna come out of this. I'm gonna pause this video here and continue when this is done. Alright, and we're back, and we're still waiting for things to be finished installing, but it's almost there. We'll see if it makes a difference if we have this thing here now. It did build it, but no, it's gonna stay at 338 megabyte. I'm gonna note that down. That's quite a lot compared to the Python 3 Slim image. But what we didn't check yet is if it actually is able to run. No. We cannot start the container as it is. Let's just try to up it with Docker Compose Up. No, it's immediately exiting. So it's not only bigger, it's also not working. So don't get me wrong on this, Alpine is completely fine, but it does not fit in our use case of what we want to do in here. So this we're gonna remove. And basically I'm gonna be out of options now because the Python 3.5 Slim is really good already. Let's rebuild this so we have it. And let's find out if we can optimize anything here. The answer to that is yes, we can, most likely at least, because pip also keeps a cache. Maybe we can reduce a little bit from what we need from this cache. Let's first of all again verify the image size. It's 193 megabyte. I hope I didn't look at the wrong thing here. No, the last one about a minute ago was 338. Okay, so this is the one we're looking at, 193 megabyte that we just built. It's pulling it from cache, so that's why it is 18 minutes ago. Now, what we can do is we can clear the cache. Docker pip clear cache. Let's see. So there's a minus no cache tier option. That would work too. And we're just gonna try that out, I guess. Let's see what happens if we can reduce our size even more. So, almost there. All right, it's done. And Docker images. We need to take a look at this. 181 megabyte. Did this just go up? No, it actually didn't. So Python 3.5 Slim without pip cache, 181 MB. It's again 12 megabyte. Okay, no, not much, I know, but still. We're gonna just double check that we can still run this. That pip is still working. Pip freeze. Yep, pip is working. There's Django, there's Celery. Manage py check. And seems to be working. Run server. Also seems to be fine. Everything is fine, I guess. So, mission accomplished. We did reduce our Python image from 751 megabyte down to 181 megabyte. I'll actually commit this because there's nothing wrong with that image. I like the way this image is. And like I said, a small image that you have for your application will improve your efficiency on so many other levels. And it will reduce your attack surface. I'm gonna link another article below in the description, or a YouTube video, I believe, from one of the Google engineers that will tell you more about the attack surface and why Google wants to choose smaller images, or why they recommend smaller images rather than bigger images. And what's left for me to say is thank you for watching. If you have any comments or questions, please ask them. If you manage to get a working installation with Python 3.5 Alpine with Postgres, please feel free to share it in the comments. I'll probably upload it to something so everybody can see it. All right, thanks, bye, and see you next time.